Hi everyone, and welcome to this series of practice problems in numerical method topics. And today we'll solve a couple of examples related to numerical integration. And in numerical integration, we'll talk about trapezoidal method and 1/3 Simpson rules. Before that, I'd like to explain a very important point. Whenever you are asked to solve a question that is asking to solve both the trapezoidal and the 1/3 Simpson rules, and you are giving certain h, we need to understand what is the meaning of h and n when these two methods are brought in the same context or in the same question. So to explain this, imagine that we have this curve here, and basically this is A and this is B. And we use the trapezoidal method. Here, clearly, your n is basically is equal to 1. The most fundamental 1/3 Simpson rule, because we are using basically a second order polynomial to fit the curve in between. So we will have A, we have B, and in between we have A plus B over 2. So as a matter of fact, we have here n equal to 2. So n equal to 1 equivalent, or the start, which is the starting point of the trapezoidal, is basically is n equal to 2. So every time we find an n for a trapezoidal method, n for the equivalent 1/3 Simpson rules is double that. Another way to look into it, when we have multiple areas between or divisions, not just n equal to 1, so here we have multiple areas here. So the increment here is basically just h. But when we use basically here for the 1/3 Simpson rules, so when you go from here to here, this is plus 2h, 4h, and in between we will have the h here. But the integration of one area is over 2h, not just 1h. So what I want to say here, whenever we found h and n for basically the trapezoidal method, h for 1/3 Simpson rule will be h over 2 of that, and n times 2. So I just want to make sure this is clear before we start solving the question. So let's start with the first one. It said here, estimate the integration for h equal to 0.04 using both the trapezoidal and 1/3 Simpson method. And then we want to estimate the error using both methods. Okay, so we'll start with the trapezoidal method here. And then we will go for the, basically, we will go for the 1/3 Simpson rule. Now, when h equal to 0.04, your n will equal to basically 5, which is 0.6 minus 0.4 divided by 0.04, which is equal to 5. So for the trapezoidal, we have n equal to 5. So we want to, and this is the equation for the trapezoidal method. So this is I is equal to b minus a, which is 0.6 minus 0.4. This is the limit of the integration over n to n. N is 5, so 2 times 5. F of a is the starting of the integration of 0.4 plus 2, the summation over I equal to 1 to n minus 1, 5 minus 1, which is 4. So we'll have here 3 terms. F of a plus I times h is 0.04, plus f of b, which is the end of the integration, which is 0.6. So this is equal to 0.2 divided by 10 f of 0.4 plus 2 times. Now, a is nothing but 0.4. And then I goes for, this is 4 minus, this is 4. So we have I equal to 1, 2, 3, 4. So we have 4 terms. So f of 0.4 plus 0.04, which is 0.44. And then we'll add 0.04 each time. F of 0.48 plus f of 0.52 plus f of 0.56. And then we will have f of 0.6. So that is the total integration. And when we basically calculate all these terms, now we need to substitute here. This is your f of x. Now, just remember that for the 3x, for example, f of 0.4, this is 3 times 0.4, f of 1.2, you have to make sure that is in radian, not in degree, of course. And this will give you a total value of 0.538114. So that is the value for h equal to 0.04 using the trapezoidal method. Now, let's go for the other one, was 1/3 Simpson method. Now, as I mentioned, there n is equal to 5, n here will be equal to 10. So that is something very important to basically to notice. Okay, so your I equal to b minus a. Now, b minus a, this is 0.6 minus 0.4 divided by 3 times 10, f of a starting with the integration of 0.4 plus 4 times I goes from 1 n minus 1 to 9. And this is odd number, so it would be 1, 3, 5, 7, and 9. F of x of I plus 2. N goes from 2 to n minus 2. So we'll have here up to 8. F of x of I. And here is n is basically even numbers. So it go from 2, 4, 6, and 8. Plus f at the end, which is 0.6. Now, how you can find the odd? This is the odd, and this is the even number. Okay. So basically here, this is your n. So we'll have 10 steps. So you will divide the area into basically 10 steps. So each one, here h is equal to 0.04. Here 2h is 0.04. So the increment now within the subdivision will be 0.02. So if you just put it here in a table to make it clearer. So we start from 0.4, then we will have 0.42, and then 0.44. So every time the increment now becomes 0.02, 0.46, 0.48, 0.5, 0.52, 0.54, 0.56, 0.58, and finally 0.6. You have to end up at the final limit. So this is 0.4, and this is the 0.6. Now let's start the odd. Now we start from the first one after the starting of the limit is your odd. So this is your odd, 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 and odd. And here it is. As I said, you will have 1, 3, 5, 7, 9, 1, 3, 5, 7, and 9. And this will be even, 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 even. Okay. And here, as I said, we said the even will have 2, 4, 6, and 8, 2, 4, 6, and 8. Now we are set to find our integration. Your I is equal to 0.2 divided by 30, f of 0.4 plus 4 times f of 0.42 plus f of 0.46 plus f of 0.5 plus f of 0.54 plus f of 0.58 and close the bracket plus 2 f of 0.44 plus f of 0.48 plus f of 0.52 plus f of 0.56, close the bracket, and finally f of 0.6. Now, when you substitute and calculate, you will find that this is equal to 0.53844. You can try and find the actual integration. You can find that, and then you can see the error. You will see that this is very close to the actual integration. Then the question is asking us to find basically the error. Okay, so here the error that we will have here using the trapezoidal, this is the function f, and the error is less than or equal to b minus a, which is 0.6, and here it is minus 0.4, and then we will have here our h square. Okay, and h here is as we have it as in the question here, 0.04, 0.04. Okay, now we need to find m. M is equal to the second derivative of the function of x. So we need to find the second derivative of this. So the first derivative, as we know, is equal to e to the 2 of x times 3 cosine 3x plus 2e to the 2x sine of 3x. If double prime of x is equal to now e to the 2 of x times minus 9 sine of 3 of x plus 6e to the 2 of x cosine 3 of x. So that is the derivative of the first term. Now let's go for the second term, plus 4e to the 2 of x sine of 3 of x, and plus 6e to the 2 of x cosine 3 of x. Now collect terms. This and this will give you minus 5e to the 2 of x sine 3 of x plus 12e to the 2 of x cosine 3 of x. So that is basically the second derivative. Now you go and substitute here. Now your m will be this is the maximum value this can get within the limit. So your m is basically will equal to 25.218. So that is the maximum value you can get when you substitute the two limits and see which one is the highest. And then your error basically here will be equal to or less than or equal to 0.00067. So just substitute here. You have everything here. Just substitute, you get this value. Now, to find the error using the 1/3 Simpson rules, this is the formula here. Now your h is 0.02 and your m is the fourth derivative. Now I will not do that. So this is the fourth derivative of x. I will just give you the value is equal to minus 119 e to the 2 of x sine of 3 of x minus 120 e to the 2 of x cosine of 3 of x. You can try this, and from this you will find that your m is basically equal to 350.29, and this happened at x is equal to 0.46. Just for consistency here, this happens at x is equal to 0.6. So this is the maximum value that happened for m. Here, the maximum value doesn't happen at the two ends of the integration. You have to try different values, so it happens only at 0.46. You can equate that to 0 and find the minimum value using as if it's an optimization problem. This is one way to do that. And then you will find that your error basically is less than or equal to 6.23 times 10 to minus 8. That is basically your, or much less than the error that we have it using the trapezoidal method, and that is basically expected. So that is for continuous functions. Now let's go or known function. Let's try to solve this for a discrete functions. And basically here you want the integration from 1 to 1.8, and you are given as time as or x steps 0.1 each. So your h between one to the other is basically equal to 0.1. That is the minimum h. You have it from the trapezoidal perspective. Here for h equal to 0.4, 0.2, and 0.1, we want to find basically the integration using the two methods. So let's start with the trapezoidal. This is the relationship. So this is basically your b is equal to 1.8, your a is equal to 1. This never changes. So this will be your f of 1, and this will be f of 8. Now here your h is 0.4, so this h is 0.4. We need to find your n. Very straightforward. Your n is equal to b minus a, which is 0.8 divided by 0.4, which is equal to 2. So your n here is equal to 2, or this will be equal to 1. So f of a, this is your 1, and this is basically will be 1. So this will be equal to your integration I is equal to 0.8 divided by 2 times 2. Okay, f of 1 plus 2, f of 1.4 plus f of your 1.8. This is 1.8. So we have all the values. So this is 1.4. Just substitute here. You will find that the integration is equal to 1.791. So this is for h is equal to basically is equal to 0.4. Now let's move to the second one. And let's find for h now is equal to basically 0.2. And now as we reduce h to half, the number of n will double. So there n equal to 4. Here 2. Here n will be equal to basically equal to 4. So again h, it is basically 0.2. Okay, and this is f of 1, and this is f of 1.8. This will be 3, so we'll have here 3 terms. Okay, so I goes, this is 1. So 1.2, 1.4, and 1.6. So your I is equal to b minus a, 1.8 minus 1, divide 2 times 4. F of 1 plus 2 f of, this is 1.2. Now the increment h is 0.2 plus f of 1.4 plus f of 1.6 plus f of 1.8. So we have all the values, just substitute here, and you will find that the integration is equal to 1.77229. The last one for the trapezoidal, again here we will have h is equal to 0.1, and this is the minimum. This is the minimum allowed h that you can have. If we want to go for lower than h, we cannot use this data directly. Then we have to find a function that fits the data to go for a lower h. So if I want to use that directly, the discrete data, that is the minimum h that I can have. And for this, your n will be equal to 8. So this will be basically 7. So here we'll have f, and this is basically is your 1, and the increment will be 1. Will be 0.1, so f 1.1, 1.2, 1.3 until you reach to 1.7, and the n will have f of 1.8. So your I is equal to b minus a, 1.8 minus 1 divided by 2 times 8, f of 1 plus 2, f of 1.1 plus f of 1.2 plus f of 1.3 plus f of 1.4 plus f of 1.5 plus f of 1.6 plus f of 1.7, close the brackets, and this is plus f of 1.8, and when you do the integration, you will find the value is equal to 1.768. So this is how we can find basically our integration using the trapezoidal if we have a discrete data. Now let's go now for the basically for the 1/3 Simpson rule, and we need to use the same h, but as we mentioned before, so when h is basically equal to 0.4 in the trapezoidal, this is equivalent to h is equal to 0.2. Here your n basically will be equal to 2, but here n will be equal to 4. Okay, so here this will be 3, this will be 2, so we'll have here 2 terms here, 1 and 3, and here we have 1 term. Okay, so let's try to see this. So your I is equal to 1.8 minus a, which is 1, divided by 3 times n, which is 4, times f of 1 plus 4. Now here we want to, the increment that we'll have is 0.2. So we'll go from 1 to 1.2. So 1.2, this is your, so we start from here, and then the first one, which is odd. So we start from the starting of the integration, odd, even, until we reach the end of the integration. So this is your starting of the integration. So this is your first odd. This becomes f of 1.2, and then this is your second. This is your second. Sorry, this is your first odd. This is your first even. Then this is your second odd. Okay, so plus f of 1.6. As I said here, plus 2 for the even, you have only 1.4 plus the end, which is f of 1.8. So starting the integration, your h, you will start your first odd, then your h even, odd, and then the end. Okay, so we have at 1.2 and 1.6, and here you will see that the distance between the odds are the 2h, or the h from the trapezoidal. Now let's substitute all the values. We have everything here, so we'll get the value equal to 1.767. Now let's go back to the values of the integration. So here 1.791, 1.7729, and then 1.768. It looks converging. Now here directly we come very close to 1.768 here. So it seems that this is the conversion value. Now let's go for h. Second one, from the trapezoidal, when h is equal to 0.2, that is equivalent in the 1/3 as h is equal to 0.1, and n here basically will be equal to 8. Okay, so this is for the existing one. So here the increment, so we start from here. So this is odd, 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 and odd. Here it is even, 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 and this is the end of it. Okay, so your I is equal to b minus a 1.8 minus 1 divided by 3 times n, which is basically 8. F of 1 plus 4, the odd number, which is f of 1.1 plus f of 1.3 plus f of 1.5 plus f of 1.7. So we will have here basically 4 numbers, close the bracket, plus now 2 for the even, which is f of 1.2 plus f of 1.4 plus f of 1.6. And then finally plus the end of the integration f of 1.8, and this will give me a value of equal to 1.7667. See here, compared to the previous one, they are almost the same. Okay, so this means that we are basically converging and converging faster here for the 1/3 sensor rule. Now for the last one, for h is equal to 0.1 in the trapezoidal, this is equivalent to h equal to 0.05 in the 1/3. And since the increment that we have here is basically only 0.1, so we cannot actually find it for this h, the 1/3. The maximum or the minimum value of h we can go for is basically when h is equal to 0.2 in the trapezoidal or 0.1 in the 1/3 Simpson rule. Yes, I said we can bypass this by finding the function, but for this I don't want to go any further. I will say, okay, this is cannot be solved.